Now we're going to get to one of the crucial things in this course is how to solve a linear equation. So what is a linear equation? Well, all linear equations can be written in the form ax plus b equals c. At some point, they could be written in that form, where a, b, and c are real numbers. So x is representing the variable. Okay, so they might not start out looking like that, but that's eventually what they will turn into, and then we can solve the linear equation. So I thought I would go through the steps first. First, simplify the left-hand side and the right-hand side. Okay, so you do it separately. You're going to simplify the left of the equation, the left side of the equal sign, and you're going to simplify the right side of the equal sign. That'd be step one. Step two, get variables on one side. Step three, get constants on the other side. Four, divide by the coefficient to get variable. Well, I'll just put divide by the coefficient. Okay. So, and then finally, we usually like to check our answer to see if it's right. And those are pretty much the steps. Okay, now they're listed in your book. They might be worded a little bit differently. That's fine. I would suggest you read the book too if you have time, and or if you feel like you have more questions. Okay, so now let's see how we can put this in place. So first example 2 here, I guess second example. We're gonna simplify the left-hand side. So I've got to distribute the 2m minus 8, so that's the distributing, plus 3 equals -1. Okay, now I would go ahead and combine any like terms that you have. It's part of the simplifying. So 2m minus 5. So hopefully that's not a problem. You have -8 plus 3. That's going to get you -5 or -5. You can make it plus a -5 if you like doing that. Okay, now we're allowed to add any real number to both sides. And so we don't want that -5 there on the left. We want it on the other side. So what we're going to do is we're going to add 5 to both sides. Sometimes students like to write it this way. I've seen it written other ways, but this is one way you could write it. So you get 2m equals, now you've got to combine -1 and 5. That's going to be 4. And then so we just have the one variable m by itself there. You know, there weren't any other m's running around in the equation. So we kind of could skip the step 3, I think it is. No, step 2. So we already had just m. But we had to get the constants over on the right-hand side, so we did that. So now we're to the division. We want it to just be m equals something. That's the whole goal of solving these, to get the variable equal to some value. So we're going to divide by the coefficient, which is 2. And I usually write it that way. So I get m equals 2. Now, you can put that in and check it, see if it works. It does. I'm just checking it in my head. But you can write that out. I'm not going to. You can do that later. Okay, so now we'll go to example 3. It's a little bit different. We have this fraction in here, but we're still going to distribute, and hopefully things will work out nicely. So 1/3 times 6u plus 1/3, dot there for times 3. Now on the right-hand side, I don't have any distributing to do, so I'll just copy it down. So I'm going to simplify 3 into 6, 2u plus, and then those 3's cancel. So I do get a 1, by the way, there. I need that 1. equals 7 minus u. Now notice that you have u on both sides of the equation. You have a u on the left and you have a u term on the right. We have to get them together. So I'm going to add u to both sides. When I do that, this part will add up to 0, so we know that from our properties. So on the right-hand side, I just have a 7. And then on the left-hand side, I now have 2u plus 1u is going to be 3u plus 1. And now I'm into that form of a standard, or of a linear equation. I'm going to subtract the 1 from both sides. So that part's 0. And I have 3u equals 6. 7 minus 1 is 6. I'm going to divide both sides by 3. And so I'm going to get an answer of u equals 2. And then there's just more examples that get bigger. Okay, so hopefully this is making some sense. If not, come to class and I can go over some more examples or explain things. Or you can always see me in my office hours as well. Okay, on the left-hand side, we've got some distributing here. So we're going to go 6p minus 18 minus 7. We also have distributing on the right-hand side. So we get 20p plus 15. So I'm just making 5 times 4p, 20p, 5 times 3, 15, minus 12. I'm going to go ahead and do some simplifying now on the left. 6p minus 25. And on the right, 20p plus 3. So I do that combining of the constants. Okay. Now we have a question. Some people would want to subtract 6p. I think I'll do that this time. A lot of times I just put the variable on the left because negative numbers don't bother me, but you can go to the right as well. So I'm going to subtract 6p off both sides. This says, hey, I'm getting the p's all on one side. So now I have a negative 25. I've got to make sure I remember to write the negative. And then this is going to be 14p plus 3. Now I need to get the constants on the other side. So I need to subtract the 3. And then I'm going to have a negative 28 here equals 14p. So I'm almost done. This time though, my variable's on the right. That's okay. If you don't like it that way, you could rewrite it 14p equals negative 28. But I'm not going to bother. Divide both sides by that coefficient on the variable. And so that coefficient on the variable term is 14. So I'm getting a negative 2 for p. Now, depending on your textbook, sometimes textbooks like the solution as a set, and they'll write it this way. Sometimes they'll just write p equals negative 2, or they might just put negative 2, but that's fine. And you can check it. That's right. Okay, so example 5 here looks a little more tricky. So we've got a 6, we've got a bracket, 4, and then we're going to have to distribute right here. We're going to distribute that negative 2. So negative 14y plus 2, because you got a negative 2 times a negative 1. That's going to be a positive. I'm going to go ahead and distribute on the right-hand side. Big numbers. So what do I get? 104, I think, for that, minus 64y. I don't make these problems up, but this is what we have. Okay, now I'm going to go ahead and simplify inside the brackets. So I have 6 bracket 2 minus 14. Oh, I'm sorry. No, I don't have that. Good thing I caught the mistake before the end. Okay, so 4 plus 2 is 6 minus 14y. And then I'll mention a couple things here. I didn't take my brackets down to parentheses. Some textbooks do that, some don't. I like to keep the brackets. It just makes it less confusing to me because they were the brackets originally, the square brackets. Let's see if I was going to say anything else. I think I was, but I don't remember now. Okay, so let's distribute this 6, and I'm going to get 36 minus 6 times 14, 84. You can always use a calculator for that work? Okay. I'm going to go ahead and get y on one side. I'm going to go ahead and add 84y to both sides. Probably should have done it the other way, but too late. I already started it this way. And that's going to be plus 20y. So a negative 64y and a positive 84y is going to give me 20y. And then I'm going to subtract the 104. So I want to get the constants on the other side. And that gives me 20y on the left. Oh, then I'm going to have to borrow. Now here's what I would do. I'd probably go over to the side and write it out on paper. I'm trying to subtract here. Make that a 9 and do all of this. It's getting late in the day for me. So I would get, what, 68? Okay. And it's negative, so negative 68. Now, it's not going to work out to be an integer. That's okay. I'm going to divide by 20. Not everything works out to be an integer. We'd like it when it does, but... And then if I'm going to leave it as a fraction, which I probably would in this case, I could divide both sides by 2. No, I can divide both sides by 4. So 4 goes into 68, 17 times. So I get like negative 17 fifths. And I would just leave it that way. Or I could write y equals negative 17 fifths. I kind of like it that way. All right. So it didn't work out to be an integer, but that's okay. Not everything does. Fractions are okay.